Hi everyone. After taking a look at Lewis diagrams for individual atoms, the next step is for us to talk about diagrams for when those atoms combine in a compound. Because we're only going to be working with nonmetals, the kinds of compounds we're going to be dealing with are molecular compounds. When atoms combine, they're going to each obtain an octet of electrons. They're going to have 8 electrons around their symbol when we complete the diagram. There's one exception to this, which is hydrogen, which is going to form a duet, just 2 electrons. When we're finished constructing our diagrams, an atom is going to have 8 electrons around it, but hydrogen is only going to have 2. Atoms are going to end up sharing pairs of electrons, and the name for this is a covalent bond. It's this passing of electrons back and forth that holds the atoms together, bonds them together, and that's a covalent bond. It's very important to say that one bond represents 2 electrons. The number of bonding electrons from our work with individual Lewis diagrams for atoms is going to correspond to the number of bonds an atom will form. Bonding electrons corresponds with bonds. It's almost the exact same word. This is all summarized in this table. Hydrogen, fluorine, chlorine, bromine, and iodine all have one bonding electron. They're all going to form one covalent bond. Anytime we do a diagram that has hydrogen, fluorine, chlorine, bromine, or iodine in it, it's going to have one bond. Oxygen, sulfur, selenium, and tellurium, mostly just oxygen and sulfur are what we're going to see, have 2 bonding electrons, so they're going to form 2 bonds. Anytime there's a molecule that has oxygen in it, that oxygen is going to have 2 bonds. The same for sulfur. At 3, boron, nitrogen, phosphorus, and arsenic, we're not going to see arsenic very often, all have 3 bonding electrons. They're all going to have 3 bonds. Carbon and silicon, 4. Anytime we do a molecule with carbon in it, that carbon must have 4 bonds. We're going to do diagrams in 2 different styles. The first is a Lewis diagram. We already talked about Lewis diagrams for atoms, but now we're talking about Lewis diagrams for molecules. It's a little bit confusing that it has the same name, but one for atoms, one for molecules. When we do these diagrams, the shared electrons get replaced with a dash. The bond is shown as a dash. And the lone pairs that we explored in the last video are included in the Lewis diagram for a molecule. So let's say all of this in a different way. Oxygen is always going to form 2 bonds because it has 2 bonding electrons. But those 2 bonds are going to be dashes. Anytime we do a molecule, a diagram of a molecule with oxygen, there's going to be 2 dashes on the O. If we see boron, it's always going to have 3 dashes on it. Carbon, which we're going to see a lot, is always going to have 4 bonds. A second style of diagram is called a structural diagram. It's very picky now. It's exactly the same as a Lewis diagram with one exception. Lewis diagrams, the lone pairs are shown. A structural diagram, the lone pairs are not shown. It is important to say that there are times where the Lewis and the structural diagram might be exactly the same. There might not be any lone pairs. We're going to see a bunch of examples for that in the next video. As we work through those examples, keep in mind we're always going to be on the lookout for an octet and a duet for hydrogen. The places where we're sharing electrons are going to get replaced with dashes. And our double check is this table. Ultimately, if this table right here is satisfied, we know that we've made a correct diagram. And I hope that helps.